Hi, and welcome to episode 7 of Johnny Does .NET. My name is Johnny Hooibergs, and in this series of videos, I'd like to tell you more about my favorite programming platform, .NET. In this episode, I'll talk to you about the different templates that support Windows desktop development, templates like WinForms, WPF, and WinUI. You are able to create Windows desktop applications using the .NET CLI, Visual Studio Code, or Visual Studio. The reason I am using Visual Studio is because Visual Studio can give you a designer experience, which means that when creating visual Windows desktop applications, you also get a visual designer where you as a developer are able to drag and drop components to visually design your applications. From the .NET CLI, you can only create your projects, and then you need some kind of editor to actually do this. From Visual Studio Code, you can also create and see and edit your code, but you're not able to visually design your user interface. Only from Visual Studio, but also the free version of Visual Studio Community Edition, you can actually use that visual editor. Now, we are in Visual Studio and I am going to create a new kind of project. I told you there's these different kinds of projects. There's WinForms, WPF, and even WinUI, but those are somehow different. So basically, when the older version of the .NET Framework came out in 2002, we only had Windows Forms. Windows Forms is actually the first Windows desktop, let's say, technology to actually do .NET applications for Windows desktop. So Windows Forms was the first one for .NET specifically. Now, as the years went by, Microsoft decided that there's also going to be a newer, more modern version of creating Windows desktop applications, which was called WPF. And WPF is the shorthand for Windows Presentation Foundation, where Microsoft basically decided to rewrite the Windows UI for WPF in order to make it more dynamic and also give you as a developer more visual flexibility. You can actually create nicer looking applications that do not specifically look like Windows does, because every version of Windows has a very specific look, like Windows XP, Windows 7, Windows 10, Windows 11. They all look similar, but they have their own unique style. If you create a WinForms application, your WinForms application will automatically use that same visual style for that version of Windows you're running your Windows Forms application on. Now, when you're doing WPF, you have more flexibility to customize your components to look whatever you want them to look like. So it's more modern, and it also uses your graphics card, for example, as an extra engine to render these kinds of components. While in Windows Forms, these are based on older Win32 APIs that can only render the default Windows components like we know them from Windows. So I will show you these different templates, and I will start with the oldest one, which is Windows Forms, which does not mean that it's a bad one. It's not bad because it's the oldest one. It's actually also a still a very cool kind of technology to very quickly be able to create Windows desktop applications. So you can select it from the recent project templates, or you can of course search it from your templates in Visual Studio. So it's the Windows Forms app for C#, which only runs on Windows, by the way. That's hence the name Windows Forms. So you can create this template in the directory you want with the name you want. I'm not going to make any changes, but I'm also going to create it for the most current version of .NET, which today is .NET 6. When you create a Windows Forms application, Visual Studio goes ahead and creates that template for you, and it will create one window or form as a default form for your application. So when you run a Windows desktop application, it runs a form or a window, like a physical window on your screen. Now, this window can contain different kinds of components. And these components can be dragged and dropped by you as a developer to basically design your user interface. So as you can see, while I was talking, Visual Studio it's finally ready, showing you the visual designer for this Form 1. And if I look at the Solution Explorer, you can see that this form 1 is the only form in this application for now. And next to the form, we also have that familiar program.cs. So program.cs, we already know that from console applications, and it looks somewhat similar. It's not a top-level program, but it also has that namespace, the program class, and then the main method. So when your application starts, when your .NET application starts, it will automatically run the main method. And in this case, we're not using console write lines and console read lines because we're not creating a console application. We are actually using the application class to run the form as our main form for this application. So form 1 will be the main form. So let me quickly show it by launching this WinForms app 1 project. And this form 1 will be loaded as the main form. And this is a standard Windows form or Windows window. You can see the title bar, you can see the caption, you can see that icon on the left hand side with the shortcut menu. You can see the very familiar 3 buttons on the top hand right side, like a minimize and maximize and exit to close that window. And also, when your application only has one window, closing that window will also close your application. When your application has multiple windows, you can close additional windows and your application will keep on running as long as there is one window still open, one like main window still open. So when you close that main window, of course, your application will also shut down. Now, also from the Solution Explorer, you can see that the form 1 actually can also be expanded. So we have form 1, which is the visual designer, and we have form1.designer.cs, which is a separate C# source code file that contains all of the designer code. And what basically happens is when you as a developer or designer start putting components on top of this visual designer, Visual Studio will generate code for you and it will put that code into this Windows Form Designer generated code region. And this basically just contains very silly code that puts everything in the correct spot, gives everything the correct name, gives everything the correct caption, and so on. You should not really modify the contents of this class or of this file. It will be done automatically for you. You, however, can change it. If you want to do some small modifications, you can, but you always need to be careful to not break things that are being generated for you. So I would suggest to just leave this file as is. Don't open it unless you want to learn from it, and don't change it. Just change by using the designer. Now, if I want to create something useful, for example, I can go start dragging components on top of this window. And you can do it from the toolbox on the left hand side. The toolbox is a toolbox of components that you can use. And there's the common controls or common components that contain the most commonly used kind of components. Things like buttons and checkboxes and combo boxes and labels and list boxes and so on. So all of those components will probably sound quite familiar to you because you've used them in already existing applications. There's even more of these kind of components when you expand the all Windows Forms components. Then you have a long list of all these different kinds of components that you can use. Now let's keep things simple and put a button on this Windows by selecting button and then dragging our button into a very specific spot. When you release your mouse cursor, this is where your button will live. And of course, you can drag it around if you're not happy with where you put it. You can change its size still after you put it down. And you can right click and visit its properties. And with its properties, you can change its behavior, you can change how it looks, stuff like that. So the text for now is button 1. So let's make that into click me exclamation mark. If I save this, you can see in the designer automatically it changes to that click me text that we have put here. I can even change the font size to something a little larger, like 18. Now it says click me with a larger font, so it really pops to the eye. So it's very easy for users to see that they need to click that button. And you can change all other kinds of things like alignments, like images, like colors and stuff like that. Now, I want to do something interactive, which means that if the user clicks this button, I want to show a number in the bottom, and this number will go up if the user clicks more often on this button. So I'm also going to check this label, look at its properties, change its text to 0, for example, and change its font size to something that is a lot larger, let's say 36. I'm going to put this underneath the actual button. Now, in order to make the button do something, we need to add some code to that. And we can do that based on an event handler. So this button has the concept of an event handler or events, and we can see them from the properties window if we change the current context to events instead of properties. So if you go to events, you can see all of the different events that the button supports. By default, the most commonly used is click. When a user clicks, something needs to happen. And what is clicking? Clicking is actually moving or clicking the button of your mouse down and again up on the same component. So it's like down and up on the same component. If you want to do more fine-grained events, you can actually look down into mouse and you can see that there's separate events for mouse down, mouse move, mouse up, stuff like that. So mouse down is when you click your button down. Mouse up will be when you release your button click again after moving it down. Then you have move, which is actually physically moving the mouse cursor around your component. Mouse enter, mouse leave is when your mouse enters your button and leaves when it leaves the button area while moving it. So you can use these events to do all kinds of things very specifically. For our use case, we're just going to use click. In order to add the click event, you just double click the empty space behind the click event, and it will generate a method for you with the name of the button underscore and then the name of the event, in this case click, and we can add some code in here to actually do something. So I want to have a counter, which is a number, and I want to put it to zero. And then when somebody clicks the button, I want to increase the counter by 1. And I want to output the result of that counter or the value of that counter to that label. Now, that label actually has a name. If you go to its properties and back to its actual properties, and then scroll down a little bit, you can see that there's a design name property which says label 1. So you should really name all of your components so that you can refer to them from your C# code to do stuff with them. In this case, by default, your components are named what they are. In this case, a label and then a number, like label 1. If I add a second label, it will be label 2 and so on. You can change these labels. I can change it to like counter label or something. You can do whatever you want with the name, and you can have your own naming conventions if you want. So I'm just going to name it counter label, which means I can refer to it from my code file. And so my form1.cs, which is not my designer, but the code behind, can now refer to that label by calling it counter label, and then dot, and then I can select a property from this label, which is basically the same list of properties I also have in that visual designer, but now I can change them from code. So I'm going to look for the same text property, and I'm going to use the value of counter. So I'm going to do string interpolation and add the counter as a string. The reason we need to convert it to a string is because counter is an integer and it's a number. So in order to increase this, we need it to be a number, and then we need to convert it into a string because the text on a label is a string and not a number. Now, if I run this application and I did not make any mistakes, it should hopefully work. So I've got my form1 window, I've got my button, I've got my label, and whenever I click the button, the label will increase by 1, or at least the value inside of the label will increase by 1, as you can see right here. So it works. So this is a very basic introduction of what WinForms can do for you. you can go ahead and browse all of these different kinds of components we have in the toolbox. You have to be a little bit patient for Visual Studio to generate the content when the designer loads, but you can just create whatever kind of visual Windows desktop application you want. Also, when you compile your application or when you run your application, it behaves very similar to, for example, a console application. If you look at the actual compiled result, it's the same bin debug directory with the platform you're targeting, which is .NET 6 for Windows specifically, and it has the same executable and DLL files we know. Again, the executable is a wrapper around the .NET runtime, and then the DLL contains all of your code. So it's very important to keep these two together. If you want to run your application, your WinForms application, you just double-click the executable and it will run your window and it will actually work the way you designed it to work. So this is our WinForms application. Now, this was WinForms, the older Windows desktop technology. Again, I still use it today when I want to create something visual very quickly, because I like the fact that you can just drag and drop on top of your designer window. You can then change properties and then you can add event handlers that actually execute some code depending on what the user actually does. Now, let's look at another technology, another template in the .NET SDK that we can use to create similar kinds of applications, but with more flexibility. So I'm going to do File, New Project, and I'm going to select the WPF template or Windows Presentation Foundation. So you can find it by searching for WPF, and there is the WPF application for C#. Again, provide a name for your project, a location, select the version of .NET you are using, in our case the current version .NET 6, and create in Visual Studio. Again, we need to be a little bit patient for Visual Studio to generate the project for us and to load the window or form into its designer. And immediately you can see similarities to WinForms, but also things that look very different. First of all, we have a designer, which is very similar. But second of all, we now also have another kind of language, which is called XAML. XAML is a kind of XML-based language that we use to design our user interface. XAML actually is short for the Extensible Application Markup Language. So it's extensible, and we can use it for markup of our visual Windows desktop applications. Now, you can use this very similar to WinForms by using the toolbox, by selecting the commonly used WPF components or all of the WPF components, but we also have stuff like buttons and labels, just like we have in WinForms. We can click it and we can drag it on top of, let's try that again. We can click it and we can drag it on top of our designer. And you can see already a small difference. It looks a little bit different. And it also has these helper lines that show you that this button is located 97 pixels from the left and 132 pixels from the top. You can also see the XAML or Extensible Application Markup Language change when you are actually performing these operations on top of that designer. It will basically generate this XAML code for you. And the button has the text button inside of it. It has horizontal alignment of left, so it's aligned to the left. It has a height of 101, and it has a margin of 97 pixels from the left, 132 from the top, which I already told you, but then 0 and 0 from right and bottom. So there's actually two ways of doing this. You can just do the same thing like you're already used to from WinForms, or you can immediately start typing inside of this XAML window if you like that. And actually I prefer to type it into the XAML editor directly because it gives me more fine-grained control over where I want to put my components. And if you want to do very specific things, sometimes it's even impossible to do from the visual designer. So I basically like WPF more because I can really have that fine-grained power of writing the XAML code myself. And here, it's again a little bit similar to WinForms, where in WinForms, it will generate C# code for you. And I told you in the designer file that you should not change that code because it's very specific to the automated generated code. In this case, we don't have the automatically generated C# code, or at least you don't see it. It's not available to you. If you look at the Solution Explorer, you can indeed see that there's no program.cs, there's an app.xaml, which is your root for your application. But you have your main window.xaml and you don't have your designer file. You have your C# file that contains your event handlers and stuff like that, just like in WinForms, but we don't have the designer file. The designer file is invisible. It actually exists, and actually this XAML code will be compiled into C# code, but we don't see that C# code, so we cannot make any changes to it. We can only make changes to the XAML code, which I think is a good idea, because if we are not allowed to make changes to automatically generated code, I don't want to see it, because I'm a developer. When I see code, I want to change it. So very, very important that we don't see it in WPF. Now, let's try the same thing. Let's try to create the same kind of application we did before in WinForms. So I'm just going to remove this button and start from this, let's say, XAML template, which is a window. And so it always starts with a tag and it ends with a tag. And in between those two tags are the content for that specific tag. So the outside tag is a window, and then inside of its hierarchy, there's a grid. Now, a grid can be divided into columns and rows. In our case, I don't want to I don't want to go through the hassle of creating rows and columns. So I'm just going to use this grid, and I'm going to put inside of this grid another kind of container control, which is a stack panel. A stack panel is a container control that stacks all of its children on top of each other by default. And so if I want to have a button and then below a label, a stack panel is a good idea because it will stack the button and the label on top of each other. So inside of the stack panel, I can do a button, just like this. And now you can see, if you look very carefully in the top, there's a very, very narrow button. The reason it's a narrow button is because in WPF, everything automatically sizes depending on its context. So this button is inside of the context of a stack panel. A stack panel by default stacks vertically, which means that the stack panel by default will use all of its available horizontal space. That's why it's the complete width of the window. And it will stack components on top of each other with as minimal space as they need. My button does not contain any text, so there's no text, so my button only needs a very small border. And inside of the stack panel will also give it this space because it's what it needs, but not a pixel more than what it needs. So if I add some text, which is actually called content in WPF and not text, if I add some text like click me, you can now see that the button grows a little bit taller. So again, the stack panel will give it what it needs in order to display the text click me. Now, I think that this button is a little bit too wide. I want to make it more narrow. So the stack panel has some properties. For example, horizontal alignment. And horizontal alignment by default is stretched, so it will use all of its available space within that grid. I can also put it on center. And now it will automatically center, and it will only use as much space as necessary. Again, as much space as necessary is the width of the button that lives inside of the stack panel, and the width of the button is at minimum whatever is inside of the button. And there's text inside of the button, which is click me, so it needs that space to show click me. So that's the only space the button actually needs. Now, I think that the button is still too short or too close to the top of the window. So I can add some margin around that button. or I can add some margin around the stack panel. I can choose. In this case, I will show you to add some margin around the button itself, and let's say 10 pixels. And now indeed you can see that on the left hand side, top hand side, right hand side, also bottom side, but you can't see it, there is 10 pixels of margin. You can see the border for the stack panel, which is just a visual aid. It's not a visible border when you run the application. It's only a visual aid in our designer. But you can clearly see that the button is now a little bit away from the edge of the window. Now, I'm doing all of this stuff, and you probably think, oh, you know all of this stuff by heart. Well, it's a little bit of experience. I have some experience with WPF, so I know what different components are named and what properties they have. But you can also learn this by clicking a component and looking at its properties. Just like in WinForms, every component has a list of properties and a list of events, just like WinForms. It's basically the same thing. And you can learn from that. If you want to change a property, like the text, for example, or the font size in this case, you can see a font size of 12 pixels. Let's make it 24 pixels. And you can now see that the text indeed gotten larger. Now, if you change this value and you look at the XAML, you can see that the font size property has automatically been added. I didn't type it, it got added automatically by this properties window. So you can learn this by changing properties within the user interface from Visual Studio. It will then add to your XAML. You then know what the property is named, so you can reuse it in the future without actually visiting your properties window. But the choice is yours. You can do everything from the properties window, or you can do everything from XAML, or you can mix and match between the two, like I did for you right now. For example, I also know that in this case, I think that the click me is a little bit too close to the edge of the button. So I also want an additional margin inside of the button. And I remember from the past when I used WPF that this is called a padding. So padding is a margin within the button, while margin is a margin outside of the button. So padding equals 10, which also makes my button look less cramped. Now the click me caption or text is a little bit further away from the edges of the button by just changing this padding. By the way, you can change margins and paddings all around. For this, in this case, it's 10 for everything, but if you want to mix and match, you can do like 10 on the left hand side, 20 on the top, 30 on the right hand side, and 50 on the bottom. And then it looks something like this, where the text is not centered because the paddings all around are different. If you want them all to be different, you can just type your value only once and it will be copied to all 4 values. Okay, let's continue with actually doing something, which is adding an additional label below the button to show the value of the counter. So I'm going to add the label component. The label component by default is of course in the bottom of the button because it's inside of that stack panel, and it will stack all of its components vertically from bottom to top in the same order as your XAML. And I can also add a content to that label equaling 0. You can now see that 0 is aligned on the left hand side. And for example, I forgot what the property is named to actually center this value. So I can think logically and search for something like text alignment, but there is no text alignment here. So let's try something different. Let's say alignments. Okay, this is interesting. I can see that there's 4 properties that have alignment. There's horizontal content alignment, there's horizontal alignment, there's vertical alignment, and there's vertical content alignment. So what's the difference between a horizontal alignment and horizontal content alignment? Probably pretty logical. Horizontal alignment will be the horizontal alignment for your label, and horizontal content alignment will be the alignment horizontally for the content of your label. So if the content of my label is 0, and I want to center that 0, I could horizontally align the content to center. Yes, indeed. My 0 is now centered in the bottom of my button, which is perfectly fine. So also when doing this WPF, but also in WinForms, just experiment, just make it into an adventure. Just try and find the names of properties, and then the IntelliSense from Visual Studio will show you what you can do with whatever you are trying to find. Of course, you need to think logically, and you need to have some kind of experience to know how all of these properties are named, but they are quite logical in names. Now, adding event handlers is very similar to what WinForms does. So we have the button. If you click the button and again look at its properties, and then change the properties window to events instead of properties, you will see the same kinds of events with those empty boxes. So I can double click this empty box just behind the click event to create the event handler. But you can also do it from XAML if you want. So again, if I go to my button in XAML, you can, as you can see, you can use multiple lines to have all of these properties. And here I can search for click. In this IntelliSense window, you can immediately see that click is not a property, but click is an event, just because of this visual hint. You can see this lightning here, yellow lightning, that shows you that click is an event. Now, if I add this property, Visual Studio also suggests to create a method that will act as that event handler. So I can create this method button base underscore on click to actually do something with clicking that button. So now I can do the same thing. I can create that integer counter which equals 0. And then inside of the button click event handler, I can increase the counter value with 1. Now I need, of course, also to reference that label and find the name of that label in order to change its content or text property. Now, this is a little bit different from WinForms. In WinForms, every component has a name by default. In WPF, every component does not have a name by default, and you need to give it a name if you specifically want it to have a name. So for our label, I want to refer to it from my code, so I need to give it a label in order to do that. So I'm going to do x:\name equals counter label, and only now I can refer to it from my code. So counter label dot content equals the interpolated string, which uses that counter value inside. There we go. If I didn't make any mistakes, I should be able to run and show you that I indeed have a main window with a click button and a label that will increase when I click the button. Something very cool in WPF, which I already talked about in one of my earlier videos, is the support for changing your code while your application is running. So if I put my application on the right-hand side and my Visual Studio on the left-hand side, and I go, for example, to my XAML, I can fiddle around with properties of these components, and they will automatically change, hopefully, when I make changes to them. So this label, for example, has a font size of 20. If I want to make it bigger, let's say 30, on the right-hand side, you can immediately see it change. 30 is not large enough for me, so let's make it 300. Oh, maybe 300 is a little bit too much, so I can go back to 150, let's say. Okay, I can live with 150, so I'm quite happy with this result. So this gives you a lot of flexibility. You can run your application. It will then look like whatever it is you're doing based on the data you are using, and because sometimes it's not possible to show you the correct user interface in the designer, because your user interface is very tied to whatever data it is that you want to show, and maybe that data is not available inside of your designer. So it's very cool that you can run your application, put some test data inside of your application, and then see what it will look like at runtime, and then change these XAML values at runtime to just make it perfect, so that you are quite sure that this is what you want by just changing these values, fiddling around with these values. A very, very powerful feature, I think. Now, I told you that WPF is more flexible. What do I mean by that? Well, you have almost complete flexibility on what your application will look like. Take, for example, this button. In WinForms, you are able to put text inside of a button, but in WinForms, you are actually able to put content inside of a button. And what's the difference between text and content? Well, text is text. That sounds quite logical. Now, content can be whatever you want. It can be text, but it can also be an image or a video, a moving image. But it can even be a complex hybrid of all of these subcomponents, if you'd like. So let's do something like that as an example. So the click me button has a piece of text right now in its content. So it has content equals click me. So click me is text. Now, if I want to change it to something different, something more complex, I can just remove the content property and I can change the markup to make button have a beginning tag and an end tag. Now my button starts here and ends here, just like a stack panel or a grid. And actually a stack panel or a grid also has content, and we can put subcomponents in this content. So now I can also put subcomponents in my button. So let's say, for example, I want to have multi-line text in my button. I can basically do a stack panel. And inside of this stack panel, I can have a label with content equals click me, and another label that says something different. You will get excited or something. So now you can see that my button, let's zoom out a little bit to give you some context. Now my button has multi-line text, and I can have this look different. For example, I can do like font size equals 16 or 25. And then the other one be font size equals 16. So like a large piece of text and a smaller piece of text. I can go even more wild if I want. Let's say I want to put an image on the left-hand side of those two labels with the same height of those two labels. Well, how could I do that? Well, I can create another stack panel outside of the already existing stack panel, which is a stack panel inside of a stack panel. But I can make the outside stack panel be oriented horizontally. So now we have a horizontally oriented stack panel that has a stack panel inside of it, which is vertically oriented. And then on the left-hand side of the vertical oriented stack panel, I can have an image, for example. I'm not going to pick a physical image from my disk. Let's, for now, just believe me that you can put an image inside of an image component, but let's just give it a hard-coded width of 150 or 100. Yeah, something like that. And now you can indeed see that the image is on the left-hand side, and then on the right-hand side is my two labels. So now we have, again, a horizontal oriented stack panel with an image on the left-hand side and another stack panel on the right-hand side. And then the other stack panel is oriented vertically, so it has two labels. So this is that flexibility I was talking about. You can create components, and inside of these components are subcomponents that will create a very visual experience for your users. You can, of course, when you're very good at visual design, I'm not very good at visual design, but when you are very good at visual design, you can really shape it and use colors and use fonts to really make it look very nice. So this is what WPF looks like. Again, very similar to WinForms, but it's its own technology. It uses different kinds of components, and it gives you more flexibility to create beautiful looking applications. Now, there's one more thing I want to show you, which is available in Visual Studio, which is actually a more modern kind of way to do Windows desktop applications. It's like the newest one, which is called WinUI. And WinUI is based on Windows 10 and Windows 11 SDKs. So with WinUI, you can actually create even more modern looking apps that will give you some kind of flexibility, but it also gives you a number of components that are very modern and look very similar to what Windows 10 and Windows 11 look like. So if I create this kind of application, it will be very similar, the WinUI application, to a WPF. You will also have a XAML file. You will also have this XAML code that you can edit, but you will actually not have the visual designer. So you really need to do everything from XAML, but everything else will basically look pretty much the same as in WPF. So in your Solution Explorer, you also have your main window.xaml, but if you open it, you will only see this actual code. When I run this application, which is now actually packaged as a Windows Store application. So a Windows Store application, those are the applications that you can install via the Windows Store, and they have a very specific look and feel. And this WinUI template actually tries to force you into that same look and feel and same experience for your users. So this is my WinUI desktop, which has that Click Me button. Again, it's just a regular button, but you can see that it actually looks a little bit different. It looks very specific to Windows 10 or Windows 11. Now, luckily, WinUI also has an application that you can download from the Windows Store, which is called the WinUI 3 Gallery. And this gallery is an example application that basically lists all of the available components that you can use to create these modern looking Windows 10, Windows 11 kind of applications. And so you have your basic inputs like buttons, and this is like a standard XAML button. You can also disable the button to see what it looks like disabled. There's the graphical buttons. You can put an image inside of your button, as I told you in WPF. It can have a different color based on the accent style of your Windows installation. And so, if you install Windows 10 or Windows 11, you can have an accent color and everything will use the same accent color. For me, it's purple. So my accent style buttons will automatically be purple. But if I use my application on somebody else's Windows that has an other accent style, it will also use that accent style. So your application will automatically adapt to the configuration for other Windows installations. And you can basically scroll down this list and look at all of the components. For example, we have date and time. There's the date picker, and it's a very customized date picker where you can pick a date, a month, and a year, for example. If you want to use these components, but you don't know how to use them, just look at the source code right here. You can copy the source code and you can just paste it inside of your own XAML code and run to see what happens when you put that kind of component in there. Of course, there was a button. When you clicked the button, it would actually show you some content. So I'm going to remove the demo code from the template because the button was now removed. I also need to remove the event handler for that button. But now we have a date picker. So let's try that again and show you what the replacement for our button looks like. So now indeed we have the pick a date where I can click and then pick another date, which is again a very cool component, which is now part of my application. I can just use this because it's part of that new modern WinUI template. Very cool. Again, don't forget the WinUI 3 Gallery app to show you all of these different kinds of application components that you can use in your applications, and they will basically look very similar to whatever is inside of Windows 10 and 11 already, making it much more easier for your users to adapt to your application because it looks like the things that they already know. The user interface is very familiar, the components are very familiar, which makes their life a lot easier. And with that, I talked about all three different kinds of templates that we can use to create Windows desktop applications. But I want to show you one more thing, which is actually something that I got to know a couple of months ago, which is called Avalonia. Avalonia is an open source project from some people that are not Microsoft related, but they basically created an additional template to create WPF style applications that are real platform independent, which means you don't only, which means that you can create desktop applications not only for Windows but also for Linux, for example, which I think is very cool, because by default in the .NET platform, if you go desktop application with WinForms or WPF or WinUI, you are only targeting Windows. If you want to target other operating systems, you need to use other kinds of applications, like mobile applications, for example. I will talk about mobile applications in later videos, but with Avalonia, an open source project which adds these new templates to .NET, you can actually create WPF style desktop applications for Linux, for example. And to show you, I'm just going to show you in Linux so that you can see that it actually runs in Linux. So I have my Ubuntu virtual machine, and with this virtual machine I can now add Avalonia to .NET. So I'm using .NET. So if I do .NET new, you can choose a template to create for you. So basically, Avalonia is an extension. It's not part of .NET by default. You need to install it as an extension. So there is actually something called .NET new -i avalonia.templates. So -i is an option you can use to install additional templates to the .NET new command. And avalonia.templates is the name of these group of templates that we want to add to our .NET New experience. So if you do this, these templates will be installed from the source of Avalonia templates, which is open source. You can just view on GitHub. I already had this version installed, but now it's just overwritten the already existing templates. But this is how you can basically do it if you don't have them installed yet. Now I can do make directory Avalonia tests to create a new project, and I can use .NET new avalonia.app to use the .NET new to generate this project based on that Avalonia template. Of course, we are using Linux, which means that there's no full-blown Visual Studio available here, which means I will not have a visual designer. I can use Visual Studio Code and open this folder that I just created, like the sources Avalonia tests. And it will look very familiar. We have our program.cs, we have our XAML, main window.xaml, but there is a little change here. Right? It's not XAML, it's a XAML. And a XAML actually stands for Avalonia XAML. And then the rest looks very similar. The rest is actually also XAML code that you already know from my previous example. So if I want to have a window with a button, for example, I can do button content equals click me, and then end the button right here. Now, if I didn't make any mistakes, I can use my terminal to do .NET run on this folder to compile and run this application, which should now be a desktop application, not a Windows desktop application, but a desktop application for Linux in this case, thanks to the power of the Avalonia open source project. And this is my button. Now, whatever you know from WPF will probably help you a lot with this Avalonia framework, because it looks very similar, it works very similar. So it's now very easy for you as a Windows desktop developer to also create visual desktop applications for other platforms, for example, Linux in this case, which I am very, very happy about. When you are using Visual Studio, you can also install the Avalonia package for Visual Studio. Just search for Avalonia to check these templates and create them in this way. Of course, something goes wrong right now on my system. I probably need to reinstall my Avalonia templates in order to show you, but you will basically have the same experience as in Visual Studio Code or from the WPF templates here. By the way, in Visual Studio, with these templates from Avalonia, you also have the Visual Designer available to you. So you can still visually design your windows using Avalonia, and then from your Windows environment, from Visual Studio, you can compile for Linux, copy your files to a Linux desktop environment and run it from there, and it will work just fine. So I'm very sorry I can't show you right now, but you will have to believe me. So I hope you learned something new while I discussed Windows desktop development for .NET. I talked about different templates for creating WinForms desktop applications, WPF, and WinUI. I even showed you Avalonia, an open source project and an open source alternative to the WPF for Windows specifically. In the next episode, I will discuss all about the different templates for web development and creating web applications in .NET. Did you like this video? Please give me a thumbs up, and if you like to be notified of future videos, don't forget to subscribe. And I'll see you next week.